So this was number 3 on the quiz. Find a line in slope-intercept form that passes through one of these lines. So the first thing we're going to do is find the what?
The x and y values.
Well, the first thing we want to find is the slope, right? So we know how to do that. We just did that a moment ago. The difference in the y values and the difference in the x over the difference in the x values. So I'll start with -2 minus -4. So I'm starting with this point, right? And remember, it doesn't matter which point you start with. It's just that you need to make sure you put that coordinate first on both of them. So -2 here, so I've got to start with 0 here. 0 minus 4. Is that right, Stephen? Did I do that correctly?
Yes.
Okay, all right. So -2 plus 4, -2 plus 4, and you know, even though we can do this in our heads, I would really recommend taking the extra step and writing that down, just so you don't make a sign mistake. All right. It's always better to take up a little more paper so that you don't make a math error in your head. So this is going to be -2 plus 4. It's going to be +2 over -4. So we're going to have -1/2 is our slope. Does everybody agree with that? Mm-hmm. Okay, cool. So now we've got an equation for a line that looks like this. Y equals -1/2 x plus b. So what's the other variable that we've got to figure out?
You have to plug in x and y.
We have to plug in x and y so that we can find out what b is, right? Which x and y do I choose?
I chose for -4.
Yeah.
Why did you choose that one?
So that I had a positive number with the y.
Cool. All right. You can choose either one, right? But that's usually what I do. I look at the points and I go, which one's going to be the easiest for me to plug in, right? The simplest math for me to do. So we'll do the second one like you chose there. So I'm going to plug in -4 for y equals -1/2, and then for x I'm going to put in my +4 plus b. And so that's going to give me -4 on this side equals a +2 right here, right? Plus b. So I subtract the 2 from both sides, and that's going to give me -6 equals b. Did everybody get that?
Why is it a +2? Because isn't it -1/2 times +4?
Oh yeah, it's a -2. See, there again, I'm just checking you guys. I got to make sure that your minds are working right this morning. All right? I'm fully alert, but I don't know if you are. Does that look right? That's still not right.
Yeah.
All right.
Would it be -2? Yeah.
There you go. Yeah. All right. Yes.
Yeah. On the first one, since it's 0, -2, can you just automatically know that -2 is the y intercept?
Right? Exactly. You see his point? If we graph that, this is one of the points on the line, and that is intercepting the y-axis, right? So we could have just grabbed it from there. So yeah. All right. So our answer though is y equals -1/2 x minus b. Now -2, because that's our y-intercept is -2. So this should be our final answer, right? So I was able to, with that one problem, I can test and make sure that you know how to find the slope, that you know how to rearrange equations, right? You know how to plug values into equations. So there's all kind of things going on there where we can just make sure that you're understanding the concepts. All right, are we good to move forward then? Talk about the calculator problems last week that were causing some of you some pain because we didn't have time to go over the class. Let's like I said, I apologize. Last week I did bring a calculator, but I couldn't figure out a good way to project that up there for you guys to look at. And so I did find, is this recording? Did I hit the record button? Make sure. Yes, we're recording. All right. So you guys can either watch me on the big screen or you can watch me on the little screen, right? Either one. So let me launch my calculator app here. And plug this in the TV. So you can get your calculator up, you can follow along with this. Let's see, how do I do this? Oh, the site's information. I think it's just, there's some kind of issue with gradient. So gradient wasn't really fun, but I think it's just that for a second. Let's see. All right, so here's my emulator. And pretty cool. Looks like should look like your TI-83. Let me see if I can see that on the video. Yeah. All right, that'll work. So problem 61 in the book, right? Hayden, you asked about that, and you weren't the only one. I got some questions about that via email as well. So it said you're going to graph that equation, y equals 0.5x minus 3, and then it asks you to use your graphing utility to change the viewing window and describe what the difference is in each of the graphs. And so how would you go about doing that? Well, here's what you do on your calculator. You've got this y equals key up here on the top left. If I click y equals, that will allow me to enter a function in there to be plotted on the graphic calculator. Okay, so in our case, the function is 0.5x minus 3. So I'm going to click 0.5. If you haven't done this yet, I would recommend doing this on your calculator just to make sure it's working for you. 0.5x. Now, when you enter in x, you can either click this button right here, which has the x, and it's got a T. That may be like a Greek letter T. It's got a lambda. Omega? No, that's not an omega. What is that with the? I'm drawing a blank here on the Greek letter. But anyway, it's got a couple of different options, but it's going to default to x. So if I click that button there, it's going to create an x for me, or enter an x for me. I could also do alpha, the alpha key, and go down here and I can see that there's a little x over this STO button. And so if I click that after I click the alpha key, that'll also put an x in there for me. So either of those would work. But this is the quickest way, the one with the x on the front there. So is it 0.5x minus 3? So minus 3. All right, does everybody see how that's the graph? That's the function that we're trying to graph. So now if I go over here, all I have to do is click the graph button, and it will graph that particular line for me. Huh? Super cool, huh? And so there's all kinds of ways that you can use this, right? You can do all kinds of functions in here and let it graph it for you. And we're going to see some of the stuff that we're looking at today. We're going to see that it's really useful to just sort of quick, in a visible way, see whether or not something is actually a function or not. But they asked us to adjust the window. So if I click the window, yes?
Mine just says error whenever I put a graph. That's my problem. It's like, it just doesn't work.
Sorry, let me see this. Which one? You got 83?
Yeah.
So let's see. Y equals 0.5x. Oh, it's because you chose that instead of minus. All right, you chose.
I think I have that before. Yeah.
Wow. Oh, you got a weird.
Yeah, I have this problem.
Oh wow. Yeah, you got some kind of bigger problem going on. Let me just try a simple x graph. Yeah, that's like that. Y equals this is the window. The window settings all look good. V10. Y is 10. Scales 1. Graph that. Nope. Yeah, so I would be curious. So I don't have time to troubleshoot that right now, but you sent that to me in your email, right?
Yeah.
Did you? And you looked at that error just to see if you could figure out what's going on with that?
Yeah, that's right.
I'll search that email as well, because honestly, search that error as well. I just glanced at it quickly and I assumed that it was just, learning how to do it. We didn't get to go over the problem, so maybe we can figure it out today. Yes.
I'm just sending that to whoever's missing today.
Yeah.
Can you send that to me too, since I don't have the calculator with me right now? So
Yeah.
I can store these.
Oh yeah, absolutely. Yep. In fact, so whenever I record this, I've got a YouTube user that I use just to upload class videos. So I just keep them up there. So I'll send you guys the link to that. So I don't know, I haven't decided yet if I'm going to record every class, but if I do, then I'll always post them up there so you can go back and review it if something wasn't clear and you want to watch it again. Okay, so now let's adjust the window according to the settings that they said. So the default is like -10, +10 for the X min, X max, same thing for Y min, Y max with a scale of 1. And they want us to change it to an X min of -5. X min, oh, that's funny. Let's see, X min, just, that's the marble reference there. -5, 10 to 1, and then -10. So everything else is the same. And so let's graph that and look at what happened. Because I entered in my X min as -5, my x-axis over here only goes over to 5, right? You guys see how it adjusted that in the window? So when it's graphing this thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the graph looks like it's passing through 3, looks like it's going through that, and maybe 1, 2, 3, 4, 5, 6, a little bit past the 6, so 1, 2, 3, 4, 5, 6, maybe somewhere around here. So it looks something like that. And so when we adjust the window, what we're doing, get this one right. It does. So we adjusted with our window settings there. We said basically we want the X, the minimum X to be shown to be -5, right? So that goes through there, and the X max is the +10, so right there. The scale is 1, and so that means how often do I want to see these tick marks, right? And so right now it's set to every 1. We're going to get a tick mark on there. And then Y min is -10 down here, Y max is that. So we effectively set our calculator window to this view here. Does that make sense to everybody? So you see how you can easily change that? And it's maybe not as big a deal on this line, but sometimes your graph maybe is really, really tiny. And so you might want to say something like, I want my window to just be -1, +1, +1, -1 here. And instead of a tick mark every 1, I want a tick mark every 0.1, right? So you can kind of zoom in on the graph right there. So it just gives you the ability to adjust what the viewing window is there. So we could change it. It looks like they don't change the scale anytime. But if we do -2, again, it should predictable results at -2, 10, 1, -4, and 1. So we go down here. 4, and you see how I'm like hitting the delete button to delete these guys? Like when I want to get rid of that 0 there, how I do that? I just scroll over to where that 0 is and hit the DEL button at the top here. And then that other one's got to be 1, so I'm going to scroll down and I'm going to scroll over to the 0 and I'm going to hit the delete button. So let's graph that one. So what are we expecting to happen? Now we're expecting that our window is going to go over here. Right, that's the -2. It's going to stay in the same place on the X. Did I do something wrong?
No.
Oh, okay. Y min is -4, and then Y max is 1. So we're expecting now our window to look something like this. So let's see if that works. Yep. Cool. So you're zooming in closer, and we're not going to do the last one. Does that make sense to everybody? You see how you can play around with that? There are other options on here. There's this zoom button that you can click, and you can just tell it to. When you see a list like this in your calculator, like 1 through 7, I can either hit the 2 and go directly to option number 2, or I can hit my arrow button down and hit enter. So either way works. But so let's say I'm going to hit 2, which says I'm going to zoom in. So if I do 2, it just kind of zooms in over there. Or I could zoom out, hit 3. So now it's actually back out. It may be because I messed with it specifically. let's see, it's in the box. It looks the same way. It could be. Make sure when you enter your negative here that you don't hit the minus key, because it will throw an error if you do that. So you need to make sure you say negative, the little negative key down here, negative 10, positive 10. Let me grab that. So why did Zoom didn't really move in at all? I want to play around with that. I don't remember. It's been a while since I've used the zoom feature, but you could also do something here where we'll kind of zoom in and zoom out in particular areas. All right, any questions on adjusting the window? Does that make sense? All right. Was there any other calculator issues that you had? Besides just doing that piece? No? Yes?
How do you get back to like the main page from this?
Oh, okay, so if you're on some kind of wacky one and you want to get back to, where are you exactly? What did you put?
On the window.
The window, so you're here. So let's see, if I go to clear, all that's going to do is going to clear out that value, right? So we don't want to hit clear. What we want to do is go to, there's a quit option somewhere, I'm looking for it.
It's right above mode, I think.
Right above what?
Mode.
Mode.
The second forward mode. Is
Oh, right here, yeah. So second, quit. And that should take you back to the main screen. All right. Any other questions just about usability? Something maybe you hadn't seen before? We're gonna come back to this again and use something else on it in a minute. So the key thing there is when you go in to plot your graph, and you can do multiple, right? When you go to y equals, there's like they give you 6 different graphs here that you can enter in on your actually 8, 9, 10. So you could enter in a different equation for each of those y equals, and it'll plot all of those on one graph. Okay? All right. Let's see. Second quit. There we go. Let's go through the new material. So this is section 1.2, and let's talk about functions. So what is a function? A function is, if we say a function f, using the letter f to represent that function from set A, this is just the definition that's in the book, from set A to a set B, and it shows it from A, set A, to a set B, is a relation that assigns each element x in set A to exactly one element y in set B. We call set A is the domain or set of inputs. So make sure you know the definition of domain, what that's talking about, of function f. And set B is the range or set of outputs. I'm going to use the red marker so it'll be a little darker. So when you get done writing that down, go to page 16, and I want you to see the figure that they have, figure 1.12 that they have there, because this definition can be kind of confusing until you see a picture of it. So you don't have to write this down because it's in your book, but I'm just going to kind of try to replicate it here. We got 1, 2, 4, 3, 5, 6. We got 9, 13, 15, 12, 10. And we got a bunch of other numbers over here, 2, 4, whatever. Let's say the 1 goes to the 9, the 2 goes to the 13, the 4 and the 3 go to the 15, and the 5 goes to the 10, and the 6 goes to the 6 goes to the 10, and 5 goes to the 12. We're going to change it up, and we're going to send the 6 to the 12. So it doesn't really matter. So in that diagram in the book here, set A is the time of day. So this is the time of day. And this over here, it's a temperature. Temperature's in degrees C. Yeah. So temp in degrees C. And so for this, the idea is that at 1 p.m., the temperature is 9 degrees Celsius. And then at 2 p.m., did it say p.m. or a.m.?
PM.
It is p.m., yeah. At 2 p.m., the temperature is 13 degrees Celsius. At 4 p.m., it's 15. At 3 p.m., it's also 15. At 5, I reversed them. It's at 10, and then 6 is 12. And this represents a function where the set of inputs would be this set over here, the time of day, and the set of outputs would be, so this is the domain, and the set of outputs would be the range, right? Inputs, outputs. And so the main rule when you're trying to determine whether or not a scenario like this represents a function is that this relationship has to be such that each element x in set A, so this is set A, and this is set B, it assigns each element x in set A to exactly one element y in set B. So, in other words, as long as each of these guys here only come over and point to 1, then this is a function. It's okay for 2 of these guys to point to the same one, but 3 can't point to 15 and to 12. All right, it can't point to more than one item in set B. These guys, there can be multiple items pointing to the guy over here, 3 and 4 pointing to that, but 3 can't point to 2 or 3 different outputs. Okay, so there will only be one output for every input, exactly one output for every input. So that's kind of the key. That's the key thing with functions. There's actually 4 characteristics that they list in the book, and I guess for thoroughness, I'll write those down. But each element A, this just says each element A must match an element of B. So in other words, we don't see any items here that don't point to something, right? So that's what this first one is saying. Every element here has to map to something over there. So that's these are characteristics of functions, and I'm going to abbreviate function just FN, and if it's plural, I'll do FNS. Some elements of B may not match any element of A. And so even though everything over here on the input side has got to match something over there, that's not true on the output side, that everything over here has to match something. So we've got some numbers here that are unmatched on the right side, and that's okay. You just can't have that on the left side, on the domain side. 2 or more elements of A, 2 or more elements of A may match the same element of B. And we saw that in this scenario. We had two elements in A, 3 and 4 p.m., both matched a temperature of 15 degrees Celsius, so that's okay. And then number 4, this, like I said, is the important point. It's usually the thing that kind of identifies whether or not something is a function. This is what you're looking for. An element of A, which is the domain, can't be matched with two different elements of B. The elements of B are called the range. So don't stress out too much if you're reading some of these things going, I don't really know what it's talking about. It's going to be clear as we start working with functions. But is there anything right now, I shouldn't have said that because maybe it's going to discourage any questions. Is there anything right now that you're like, I'm completely confused and I need you to understand this point, or maybe I don't get any of it? Anybody just totally lost? You are? I really do, like I said, I think it's going to be clear as we start working with some of them. But the 4 points, let me just ask this question. Do you get the 4 points? Each element of A, each of these guys have to be matched up with something in the domain. Some of these in the domain may not be matched up with anything, like what we have here. 2 or more elements of A may match the same element of B, so like 3 and 4 are both pointing to 15. That's okay. And an element of A in the domain can't be matched with 2 different elements of B, so we couldn't have 3 pointing to 15 and 3 pointing to 12. That would not be allowed. Yes?
Just in the beginning of the definition of function, that says A, F, and F just means function, right?
Function, yeah, I'm sorry. That's just my abbreviation for function.
Okay, no, I just want to make sure I wrote that down.
Yeah. So function F. So F is what we're called. That's just a letter. These could be any letters. We could call these set C and D. We could call them a function G. Then those are variables, right? That could change depending on what you wanted to use for your particular problem. But let's do an example, and maybe that'll make it clear. We're going to test for whether or not something is a function. And it's example 1 on page 17. And so they've got a couple of examples there. And the question is, do these examples represent functions? So in problem A, they give us a set of inputs and outputs, and we're trying to determine if it breaks any of the rules, right, for the characteristics of a function. So the inputs are this one are 2, 2, 3, 4, 5. And so with the output, what they're telling us in this table is what these values are matched up to as far as outputs go, right? And so the 2 here matches up with 11, and then the 2 here matches up with 10, 8, 5, 1. So if you look at that, is there anything immediately that you're like, that's not allowed because of point number, whatever, in the characteristic of a function? Yeah.
The 2 and the 2 can't match up to 11 and 10 in the
That's right. So what he's saying here is this is not allowed, right? Why is that not allowed? Well, we've got an element of A, the domain, which is this first part here, right? And this is our range now here. And we've got an element of A, 2, the number 2, that's matched with 2 different elements of B. 2 matches 11 and 2 matches 10. And that's not allowed, right? So this is not a function. And then they give us a graph. And we got -1, -1, we got -2, -2, and so this we got B, think of that as set of X, right? Each element X is set A, and Y as the B. And so our question is, we basically have a set of coordinates, right? And our coordinates are 0, -1. Actually, I should just start on the far left here. So -2, -2, 3, -1, 0, 0, -1, 1, 0, and that's not -2, that's a +2, 2, 3. All right, so there's our set of X's and Y's. So think of your X's as your A, your set A, and your Y's as set B, or your X's as your domain, and your Y's as your range. And so our question, our litmus test, right, is usually going to be this number 4. That's what's going to fail. Is there anything, do we have multiple values, do we have multiple X's that are the same, but they're matched to multiple values of Y's? That's really our question. Like, does -2 map to anything besides 3 in here? No, it doesn't. -1. See, we don't have any repeating X's, so we can just look at that and say, since none of the X's are repeating, we know we're going to be okay. Right? This is a valid function. Does everybody see that? Yeah. And we're going to see like a quick way in a minute, where if you just look at a graph, you can tell immediately whether or not that graph represents a function by doing what we call the vertical line test. All right, basically, can I pass a vertical line? Somewhere can I draw a vertical line that's going to go through more than just one point? And that will be our test for a function. All right, any other questions about that? Nope. All right, let's see. I want us to start thinking about, when I talk about functions, I want you to start thinking about that as an equation, right? Which we're very familiar with it, so you shouldn't be scared of functions. Just kind of think of those as equations. And you can represent functions by equations with 2 variables. So, for example, y equals x squared, that's a function. And we say that we're representing y as a function of x. That's what we would say with that equation. X is what we call the independent variable. And y, anybody want to take a guess?
The dependent.
The dependent variable, exactly. Who said that, Daniel? Yeah. The dependent variable. And sorry, I'm hating you said some stuff too. So y is the dependent variable, and that makes sense, right? We're going to get some value of y as we plug in a value for x. So y is going to be dependent on whatever the value of x is, right? Does that make sense to everybody? And so, like we said a minute ago, the x values are the domain. Possible x values are the domain. Possible y values are the range. Okay, so let's do an example and help us get our minds around that. Example 2, we're going to test for functions represented algebraically. So here we don't have a graph, or we don't have a set of points that are given, but they're asking us, is this a function or not? They've just given us an algebraic equation. So the first one says x squared plus y equals 1. X squared plus y equals 1. All right, and the first thing we're going to do is we're going to solve for y, so that it looks like our normal the normal way that we would write an equation, particularly like an equation, like we learned with the equation for line, y equals mx plus b. So we're going to get y on one side all by itself. So for this one, it's just going to be y equals 1 minus x squared. Everybody agree with that? If we solve for y there. So is this a function or not? Well, what it means with it being a function is that for no matter what value of I can't provide this two different values of x. No, wait a minute. That's not right. I can't have one value of x and get multiple values of y. Right? That's what we're looking for here. And would you say that's true in this equation here? Like, is it possible that the number 1 would give us two values of y? If x equals 1? No. What if x equals -1? Still good. We're only going to get one value of y. So like, no matter what value of x we plug in there, you're still only going to get one value of y. And you're probably looking at that going, well, yeah, duh, right? That makes sense. Well, what would be a scenario where that wouldn't be the case? The next example, right? So the next example is negative x. They give us an equation that's negative x plus y squared equals 1. So now let's solve that guy for y. And so we get y squared equals 1 plus x. And then we're going to have to take the square root of both sides to get y all by itself. And so we get, arrow over there, y equals plus or minus the square root of 1 plus x. Now this is a very different scenario, right? We can, a simple example would be, what if I plug in x equals 3? Well, if x equals 3, then y equals plus or minus the square root of 4, which equals plus or minus 2. So now I'm saying when x equals 3, y both equals 2, and y equals -2. And that's not allowed, right? We can't have an x value that maps to multiple y values. So you see why that one's not a function? Make sense? So, function here, not a function here. All right, so what about, let's talk about function notation. And this is where you write something as, you give the function a name, with function notation, give function a name such as f, and write it as a function of x, or any variable. It could actually be any variable. And so, if I have a function f of x, that's what the way we would write it, and we would say that you read that is read f of x. Whoops. So we like to give names, right, when we're in math. Once you've learned algebra, we like to give variables for things. And so we're just calling our function f. That's the variable that we're using to represent f. But we're saying f is a function of f. I'm sorry, it's a function of x. And so we write it like this, and we read it f of x. Okay? So the value of f, of the function f, is going to be dependent on the independent variable x. So f is the, just to label these things, f is the function name. F of x is the output. And x is the input. So So we could write something like this. We could say f of x equals 1 minus x squared. And that looks just like what we have right here, where we said y equals 1 minus x squared, right? It's just a different way to write. Think of the f of x as your y value. So let's do example 3 on page 18, see what that says. So they give us the function g of x here, and they tell us that g of x equals a value. Let's see, g of x is the function that they give us equals negative x squared plus 4x plus 1. And so they tell us for a here to find g of 2. So what would I do? Anybody know how you go about finding g of 2? Yes?
You plug the 2 into where x is in the equation.
Yeah, so it's a function g that's based on the value of x, and they give us the value of x to be 2. Right? That's what we're saying here. So we're just going to plug a 2 in everywhere that we see an x. So negative 2 squared. I would recommend just put parentheses in there so you don't make a mistake with when you square stuff, and get rid of negative signs accidentally and stuff like that. So that's what I'm going to plug in. So now I've got negative 4 in the front, plus 8, plus 1. So that's 9 minus 4, which equals 5. Questions on that? Pretty straightforward, right? What if they give us a variable? What if instead of g of 2, they say find g of t? Well, that was super easy. All we got to do is put the t everywhere the x is. Right? That's our answer for that one. And then they could give us something that was a little more complicated. They could say, what about, let's see, find g of x plus 2. G of x plus 2. So it's the same exact process then, right? We plugged in 2 for x here, we plugged in t for x here. Now we're going to plug in x plus 2 for all of our x's. So we say negative x plus 2 in the place of x squared plus 4 times x plus 2 plus 1. And so then we got to, we're going to keep our negative in the front here as we square this guy. So this is going to be x squared plus 4x plus 4. Everybody tracking with me on that? Just use the FOIL. Everybody remember the FOIL method? First outer, inner, last as you're multiplying these together. Plus 4x plus 8 plus 1. So we're going to simplify by running our negative sign all the way through here. Negative x squared minus 4x minus 4 plus 4x. And we'll go ahead and add those together. So now we're just combining like terms. And we get negative x squared. We got a minus and a positive 4x there, so those just go away. 9 minus 4 is going to be plus 5. So negative x squared plus 5 is our final answer. Questions about that?
Where'd you get the 4x from? The x squared plus 4x plus 4?
Right here.
Where's that x from?
This x? So this is x plus 2 squared.
Yeah.
Right? So think of that x plus 2, x plus 2.
Oh.
So if we do first x squared, outer plus 2x, inner plus 2x, and then last plus 4, and we combine the like terms and we get plus 4x.
Okay.
See that?
Yeah. That's it.
Any other questions? Okay, let's talk about a piecewise defined function. And I need to show you how to do this on your graph, in your graphing calculator. So a piecewise defined function just sets the domain for portions of your function. So we're just going to go straight to an example, example 4, and they give us this piecewise function f of x equals, and they say it is x squared plus 1, but only when the domain is x is less than 0. But when it's greater than or equal to 0, the function is x minus 1. And so that's what x greater than or equal to 0, that's the function that we use for that. And so they tell us to find, evaluate this function when x equals, evaluate when x equals -1 and when x equals 0. So when I'm evaluating x equals -1, so I'll give you a second to catch up. When I'm evaluating x equals -1, which function am I going to have to use? The top one or the bottom one? The top one, right? Because that's the one that's good whenever x is less than 0. X is less than 0 here. So I'm just going to say, so f of -1 is equal to -1 squared plus 1. So it's going to be -1 squared is positive 1, 1 plus 1 is 2. Right? And then when I do f of 0, I've got to use my bottom one because that's good when x is greater than or equal to 0. So I'm just going to plug my 0 in here, minus 1, so that's going to equal -1. Now let's see how we would graph that on our graphing calculators. So it'll actually let you enter in the range there directly when you're doing the, let me turn the TV on again. So you go back to your hit y equals, and if you've already got a function in there, you can just hit the clear button to remove the value that you have in there for y1, like I did. You can give the TV a second to catch up. Wow. Didn't know it needed this long. Why does it say I'm web? Oh, yes. So how's everybody doing today? You guys good? Yeah. All right. Nice. I'm doing all right. Thanks for asking. Yeah. Wow. Let's see. Well, it's not TV. I shouldn't hit that button. Probably shouldn't hit any buttons while it's doing this little thing. It'll just confuse it more. Yes. All right. Thank you. So I hit y equals to get us back to this screen. Like I said, when I went there, I had a value in there with y1 equals, so I just hit my clear button. Right, so we're going to enter x squared plus 1. So this is kind of tricky. I had to remember how to do this last night. Had to look this up. We're going to go to our, actually this part's easy. X squared, there's a square right here, right? X squared plus 1. Then we're going to enter a parentheses, and the parentheses is going to set our domain. So what we're going to do is do x again. And we're going to go to the test. You see test right above the math button? What is that, yellow or orange? I'm not really sure. What color is the second function? The second key?
Yellow.
Yellow. All right, so we're going to hit second and test. And we're going to choose number 5 is a less than sign. So 5. We're going to hit 0. And we're going to enter parentheses. So like that. Does that make sense? Anybody having trouble entering that?
Didn't hear what you said after the first parentheses.
After the first parentheses? So, first parentheses, I just do x, right, like I had before. But I was trying to tell you where to find this less than sign. And so, to find the less than, you go to second, and then test, which is basically the math button, right? And that'll let you choose by, you could either scroll down to number 5 and hit enter, or you can hit the number 5 and it'll just put the less than sign on the screen. I'm doing like 83, so it makes how did you get this function? Somehow, let's see, clear that? So no parentheses there. Oh, you did it. Yeah, okay, you don't have to. Yeah, that, okay, that's fine. All right, now I'm in parentheses. And then your X. And so go to, wait, let's see where it is on the page. Yeah. So you're going to hit the second and then alpha. Okay, and hit number 5. Or scroll down and hit enter on that one. There you go. You got it working now?
Yeah.
All right, so now if you graph, let's just graph that one and see if it works. Okay, cool. So that's our function when x is less than 0. And that's not what I expected. Maybe I do have to put parentheses. I didn't think I needed to. I'm almost certain I didn't do that last night. Well, this will be a good opportunity to show you guys how to use the insert button. All right, so if you've typed something out, you don't want to delete that whole thing and type it all in again. There's insert is right here in yellow above the delete button. So I can hit second and then insert there, and it'll let me insert the parentheses. Then I can go down here and do that again, second, insert, and I can put another parentheses in there. So let me graph that. There we go. Okay, so I guess I didn't need the parentheses. I didn't think I had to do that last night. But maybe I didn't try this exact example. So that's the first part. That's the first function. So now we're going to go back and we're going to go to y2, and we're going to enter the other function. So parentheses again, x minus 1. And make sure you do minus there. I don't know if it would like this little minus in parentheses down here. That's a negative. That's what that actually is. And then we're going to do x, second function, test, it's greater than or equal to, which is option 4, 0. And then we're going to draft that. There we go. It's our piecewise defined function. So, did you get something like that?
Well, how do you get the less than or equal to sign?
Oh, so second function. So the second key, and then the math button, which has test right above it. And then option number 4 should be the greater than or equal, right? So was anybody not able to get that on the calculator? Yes?
Mine does not, no, it does not look right. This is what I keep getting.
Oh, that's weird.
Yeah, and I couldn't get it on the last one, so I was going to ask at the end.
Well, I like
You're missing
parentheses that it comes up like that, so like one just goes from here.
Okay.
We're going to insert, insert. Put that parentheses in there. Oh!
I don't know why, it's like, it's super weird things.
Hmm.
My brother used to quiz.
Oh, you have an extra parentheses right there. And an extra parentheses there. Yeah, I think that's all it was. There were some extra parentheses in there. There's that. How in the world?
I don't know, I mean, go to the
Did you
window.
see I did the line there?
Go to window and look at that.
Okay.
It doesn't look like how y'all see it.
Yeah, let's do 10.
I can see that.
10.
Can't see
Will that reset it over?
Yeah.
Oh,
10.
This is bigger.
Yeah, I don't know what all this stuff is
I
down
don't
here.
I have no idea.
You got this fancy one.
I know, it's so weird.
That's the one. Start tracking that. See, I don't know why it's doing that line right there. But I think it's maybe something. There's nothing else down here, is there? No?
I can ask my brother because he used to spin it like 3 years ago.
Mm-hmm.
So I can ask him if he did something to it.
Yeah, it could be something. I mean, this one's kind of cool because it's color, right? So you can see which line applies to which. So it's throwing some extra stuff in there, which I'm not I'm not sure what it's doing. But you know, it is interesting now that I'm looking at it. I mean, that parentheses looks huge compared to the other parentheses.
Yeah.
So let's see what happens if I replace. Oh, you know why? It's just doing the it's just going to be square.
Oh.
That's all it is. But you've got it all kind of crazy in your
Why is it do that?
something in the window, and then. But see all these other stuff things too. Like it's possible that something's been set with stat plot or table. Yeah, there could be something in some of these other ones that it's trying to not just graph this, but graph something else. You know.
Gotcha.
But the basics are there, right? You at least got the basics.
Yeah.
Here's the reality. I want you guys to know how to use these calculators because you might have to use them in college, right? So I want you to at least be exposed to it. But we're not really on a test. I'm not going to tell you to plot it on your calculator. I'm going to test you on that on your test. But your calculator can be an asset to you when you're taking the test to kind of check your answers and make sure you've got something that's plausible, right? So that's another reason why I want you to learn how to use it. All right. So let's go to, we're about out of time. Let's at least try to finish section 1.2. The domain of a function. Sometimes the domain is not explicitly given, so you have to determine the implied domain. So let me give you an example of that. What's the domain? The x's or the y's? The x's, right? The inputs. And so, suppose you have a function like this. 1 over x squared minus 4. All right, so f of x equals that. Are there any x values that are not going to be allowed? 0.
No, wait, 4. Wait, no.
Try it one more time. You're almost there.
If I'm doing x squared equals 4,
Right.
So it can be 2 plus or minus 2.
Can be plus or minus 2, right? So what she's saying is x squared minus 4 cannot equal 0, right? That would be undefined. And so the values, if we solve x squared minus 4 equals 0, then that's x squared equals 4, square root of both sides, so x equals plus or minus 2. So that's what it can't equal. So for this particular one here, even though they don't give us a domain, there's an implied domain. And the implied domain is that x, the domain is d equals all reals except x equal to plus or minus 2. So that's how we would list the domain for that. Does that make sense to everybody? I'm drawing a blank on your name. I forgot your name.
Claire.
Claire. All right. Claire. So let's see another one where the domain would be implied, and that would be, what if I had this? F of x equals square root of x. Are there any values that would not be allowed for x in this problem?
It can't be negative.
Can't be a negative number, right? So for this one, x has got to be greater than or equal to 0. You guys agree? So we could say domain equals reals, all reals. And I don't know, have you guys ever seen reals written like that?
No.
Okay. Well, you can use that if you want to. They don't use it in the book, but I've seen it in other math books. Reals where x is greater than or equal to 0. So you could write it like that. You could say reals where x is not less than 0, right? You can say it like that, but this is kind of the easiest way to do that.
Positive works too, right?
Huh?
X is positive too, right?
X is positive
Means X is positive.
Yeah, so you can say where x is positive. Or you can do this. You can say the domain is everything from 0 to infinity. Have you guys ever seen that kind of So what does the square bracket mean?
Just set of points or
The bracket.
As it relates to 0, what is the square? How is this?
That's like a point on the graph, right? So you take that's right, there's a bracket. And then
Well, when you do a hard number that's here. So it means it includes 0, right? It's the reals where x is greater than or equal to, so it's like the equal to portion of that. It includes, if I had done this, it would be the same as x greater than 0. If I use a parentheses, it doesn't include the 0, but it's right up to 0. Okay? So any questions about that, about implied domain? And so let's do a quick example. We don't have time. Example 5, let's just see, let's just look at example 5 in the book. It's got a set of points. What would the domain be of example 5a on page 20? When I'm saying domain, I'm talking about which values? X or Y values?
The X value.
The X values. So all I've got to do is say the domain. You see the answer in the solution for A. It's -3, -1, 0, 2, and 4. Right? Those are all the X values that we're using. For B, for letter B there, it's everything, every real number. There's not any limitation. There's no X that is not valid. But for C, what X is not valid? Since C is 1 over X plus 5, yes. So the only thing that can't happen is X plus 5 cannot equal 0, right? So X can't be -5. So it's all reals except for X equals 5 and -5. Okay? Number 6a is kind of an interesting one. Because, example 6a on the next page is an interesting one because they say we have the volume of a sphere which equals 4/3 pi r squared. So that's our function, and so they're wanting to know, is there an implied domain here, or would it be all reals? And there is an implied domain, but it's not obvious. It's not because of the, is that pi r cubed actually, because this is volume. The domain is not based on the fact that we would divide by 0 or we'd be taking the square root of a negative or something like that. It's based on the fact that we're talking about volume, and volume is a physical dimension, right? And so if I'm taking the volume of a sphere, it's actually got to have a size to it, right? So in this case here, radius for the volume of a sphere, it's got to be greater than 0, right? Does everybody understand that? It's got to be a real value, right? So this would be all reals where r is greater than 0. So sometimes the implied domain has to do with that physical component of it, if you're talking about a physical object that you're taking the volume of or the area of or something like that. Okay? Everybody clear on that?
Mm-hmm. What do you mean by the reals?
Oh, the reals, I'm sorry, all real numbers. So like -infinity to infinity, right? It's just anything except for imaginary numbers would be included. Have you guys learned about imaginary numbers? So you haven't seen those, but yeah. Okay? You guys good? All right, so we only got through section 1.2 today. So your homework will only be over section 1.2, and your quiz next week will be over section 1.2. All right, I'll send out that homework assignment by the end of the day and let you guys know what it is. Okay, so it'll be in Google Classroom. Everybody good using Google Classroom? Mm-hmm. Okay, cool. Have a good one.